Welcome to Meteorology 2 subject. Today we're going to talk about different cloud types on the weather map. Before we begin, we have to provide answer on very simple question from Meteorology 1. How do clouds form? And the answer is quite simple. Clouds are a result of condensation. When the water vapor reaches the high cool air, it turns into water drops that form the clouds. This is condensation and it's part of the global water cycle. Every day we observe various types of clouds in the sky. Although they are looking like homogeneous mass, we can classify them according to their three properties. The first one is color. They can be white, they can be dark, they can be almost transparent, which is cirrus cloud for instance. They can have different shape and size, and they have different floors where they live. So we know that the cirrus is living on the third floor and cumulus clouds are mostly living on the first floor. Let's have a closer look on cloud types. We will begin with stratus cloud. Stratus cloud is a low altitude cloud characterized by its uniform gray appearance that often covers the entire sky like a blanket. These clouds typically form in stable atmospheric conditions when moist air is lifted gently, causing it to cool and condense into a layer of cloud. Stratus clouds are generally associated with overcast skies and can bring light precipitation, such as drizzle or light rain. They often have a smooth, featureless texture and have found in the low to middle altitudes of the troposphere. Next in the queue is fog. Fog is a meteorological phenomenon characterized by the presence of tiny water droplets or ice crystals suspended in the air near the Earth's surface. It occurs when the moist air near the ground is cooled to the point where it reaches saturation, causing water droplets to condense into visible water droplets. Fog can reduce visibility, creating a misty or opaque environment. Factors such as temperature, humidity, and air movement play crucial roles in the formation and dissipation of fog. There are different types of fog, including radiation fog, advection fog, and upslope fog, each formed under specific atmospheric conditions. Now to nimbostratus. Nimbostratus clouds are a type of thick, extensive, and layered cloud that covers the sky like a blanket. These clouds typically have uniform gray appearance and often extend over large areas. The term nimbo in nimbostratus indicates that these clouds are capable of producing continuous and steady precipitation, such as rain, snow, or drizzle. Nimbostratus clouds form in stable atmospheric conditions when moist air is gradually lifted over a large region, leading to widespread cloud cover and precipitation. Unlike cumulonimbus clouds, which are associated with thunderstorms and intense localized rainfall, nimbostratus clouds produce more prolonged and steady precipitation over a broader area. The base of nimbostratus usually extends over a range of altitudes, covering both low and mid-level cloud layers. Nimbostratus clouds are often associated with overcast skies and can persist for an extended period, bringing prolonged periods of rain or snow. Now to my favorite type of clouds, cumulus. Cumulus clouds are a type of cloud characterized by their distinct, fluffy and rounded appearance. They typically have a well-defined, puffy shape with a flat base and a dome-like or tower-like top. Cumulus clouds are commonly associated with fair weather, but they can also develop into larger, more vertically developed clouds, such as cumulonimbus clouds, which are associated with thunderstorms. Cumulus clouds form when warm air near the Earth's surface rises and cools as it ascends. Ascending means rising up. As the air cools, water vapor within it condenses into visible water droplets, forming the characteristic cloud structure. Cumulus clouds are often scattered across the sky and can vary in size and shape. They are most commonly observed during fair weather conditions, contributing to the picturesque appearance of the sunny day. Cumulus clouds are often considered fun to watch for a few reasons. First of all, they have playful shapes. Cumulus clouds have a fluffy and puffy appearance, and their shapes can resemble various objects like animals, faces, or everyday items. This playful aspect makes them entertaining to observe as you let your imagination run wild, picking out different shapes and figures. Cumulus clouds are also well known for its dynamic movement. Cumulus clouds can change shape and size relatively quickly. Watching them evolve and move across the sky can be captivating. Their dynamic nature adds an element of surprise and unpredictability, making the sky an ever-changing canvas. Cumulus clouds are generally associated with fair weather. Observing these clouds often means enjoying a sunny day, contributing to a positive and cheerful atmosphere. The association with pleasant weather enhances the overall enjoyment of watching cumulus clouds. Connection to childhood. Many people associate cumulus clouds with their childhood, where lying on the grass and watching the clouds drift by is simple and enjoyable activity. This nostalgic connection adds a sense of wonder and innocence to the experience. Cumulus clouds have photogenic nature. Cumulus clouds can create stunning scenes, especially during sunrise or sunset, when they catch the warm hues of the sun. Photographers often find cumulus clouds appealing for cheating, visually striking, and picturesque images. In a sense, the fun of watching cumulus clouds lies their whimsical shapes, dynamic movements, positive weather association, nostalgic charm, and their ability to create visually pleasant scenes in the sky. At that point of presentation, we reached big brother of cumulus cloud, which is cumulonimbus. A cumulonimbus cloud is a large towering cloud associated with thunderstorm and severe weather. It is one of the most vertically developed cloud types and exhibits a distinctive anvil-shaped top. Cumulonimbus clouds are capable of producing heavy rain, thunderstorms, lightning, hail, and even tornadoes. These clouds form through a vigorous updraft of warm, moist air that rises and cools rapidly. As the air ascends, it can reach high altitudes, and the water vapor within it condenses to form the towering structure of a cumulonimbus cloud. The top of the cloud often spreads out horizontally, creating the anvil shape. On this picture, you can see on top of the cloud the anvil shape. Cumulonimbus clouds are often characterized by the dark, ominous appearance, and they can extend through multiple layers of the atmosphere. Due to their association with intense weather, they play a significant role in the development of thunderstorms and can pose risks such as severe turbulence, strong winds, and heavy precipitations. Let's have a look on some examples of cumulonimbus clouds. Seeing those clouds from the ship's bridge would add some dramatic atmosphere. The towering cumulonimbus cloud dominates the sky, creating a sense of drama and intensity. Its impressive vertical development gives a feeling of power and energy. Visualizing the anvil-shaped top, characteristic of cumulonimbus clouds, adds an interesting element. The spreading canopy at the cloud's highest point conveys the immense vertical extent of the cloud. The cloud's dark and ominous appearance suggests the potential for severe weather. The contrast between the deep grays or blacks of the cloud and the surrounding sky adds to the sense of foreboding. Looking at the picture, it's easy to imagine that this cumulonimbus cloud is harbinger of impending storm. The atmosphere is charged with anticipation, and cloud structure hints at the dynamic forces at play within. In your mind's eye, you might envision flashes or lightning illuminating the base of the cumulonimbus cloud, further emphasizing the stormy nature of this atmospheric giant. Overall, a picture of cumulonimbus cloud would likely evoke a mix of awe, respect for nature power, and the sense of imminent weather events that may unfold. Cirrus is the most friendly type of cloud in my opinion, especially if we will compare it with cumulonimbus cloud. Cirrus clouds are a type of high-altitude clouds characterized by their wispy, feathery appearance. They form at altitudes above 6,000 meters and are composed of ice crystals. Cirrus clouds are often thin and transparent, allowing sunlight to pass through, and they can create beautiful patterns in the sky. These clouds are typically associated with fair weather, but their presence can also indicate changes in the atmosphere. Cirrus clouds are often seen preceding a frontal system, signaling that weather conditions may be changing in the near future. Due to their high altitude and composition of ice crystals, cirrus clouds don't usually bring precipitation to the ground. Instead, they are more indicative of upper-level atmospheric patterns and can contribute to the overall aesthetic of the sky. On this slide, you can see some wonderful examples of cirrus cloud. Look at them. They have a feathery appearance resembling strands of hair of the strokes of the painter brush. Some cirrus clouds may take on a more organized streak-like formation, often referred to as mare's tail or horse tail. These wispy streaks could stretch across the sky, creating a dynamic and intricate pattern. These clouds might partially obscure the sun or the moon, creating a halo effect as the light passes through the ice crystals in the cloud. During sunset, cirrus clouds can be transformed into a palette of colors, ranging from soft pinks and oranges to deep reds and purples. The ice crystals scatter and refract the sunlight, creating a stunning display of the evening sky. Imagine cirrus cloud resembling feathers high in the atmosphere, drifting gracefully with the upper-level winds. They create a sense of lightness and airiness, making the sky seem like a canvas of delicate artwork. In some scenarios, cirrus clouds might thicken and lower, signaling a change in the weather. These clouds, when evolving into cirrostratus or cirrocumulus, could indicate the approach of a frontal system and the likelihood of precipitation in the near future. Overall, cirrus clouds contribute to the ever-changing beauty of the sky, offering a variety of forms and patterns that captivate observers and add a touch of elegance to the atmospheric canvas. What does the color of a cloud tell you? The color of a cloud can provide some information about atmospheric conditions and the position of the sun, especially during sunrise or sunset. Here are some general observations about cloud colors. Clouds can be white or gray. Most clouds appear white or gray during the day. This color suggests that the cloud is reflecting sunlight uniformly and doesn't contain significant amounts of water droplets or ice crystals to scatter light differently. Clouds can be yellow, orange, or red. During sunrise or sunset, clouds near the horizon may take on warm hues such as yellow, orange, or red. This is because the sun's light has to pass through a thicker layer of the Earth's atmosphere, scattering shorter wavelengths and allowing longer wavelengths to dominate. Clouds can be pink or purple, particularly cirrus clouds. they may appear pink or purple during sunrise or sunset. This coloration occurs when the sun is below the horizon, but its rays still illuminate the higher altitude clouds. Dark gray or black. Very dark or black clouds may indicate a thick and dense cloud layer, often associated with precipitation. The cloud cover is thick enough to block a significant amount of sunlight. Clouds can have also greenish tint. While rare, a greenish tint to a cloud may suggest the presence of hail or strong updrafts within a thunderstorm. This coloration is due to the scattering of sunlight by hailstones. It's important to know that these observations are generalities, and the exact color of a cloud can be influenced by various factors, including the cloud's composition, altitude, and the specific atmospheric condition at the time. Additionally, pollution and other environmental factors can also impact the perceived color of the cloud. Well, especially in big cities in Almaty, you may see darker clouds much more often due to the presence of pollution in the air. And next question, where do clouds form? Clouds form in the Earth's atmosphere when the moist air rises, cools, and its water vapor condenses into tiny water droplets or ice crystals. The process of cloud formation involves several key factors. First factor is moisture. There must be moisture in the air, typically in the form of water vapor. This moisture can come from processes like evaporation from oceans, lakes, and rivers, as well as the transition from plants. Second factor is air uplift. Clouds usually form when air is lifted, allowing it to expand and cool. This uplift can occur through various mechanisms, such as convective lifting. Warm air near the Earth's surface rises because it is less dense than the cooler air above. Orographic lifting. Air is forced to rise over mountains or elevated terrain, leading to cooling and cloud formation on the windward side. Frontal lifting. When warm air mass and cold air mass meet, the warm air is lifted over the denser, colder air, leading to the cloud development. Convergence. Air converging from different directions can lead to upward motion and cloud formation. Third factor is cooling of air. As the air rises, it expands and cools. When the air cools sufficiently, it reaches its saturation point. The temperature, definition of saturation point, by the way, the temperature at which air can no longer hold all its water vapor, and condensation occurs. This results in the formation of tiny water droplets or ice crystals, which make up the visible cloud. Clouds can form at various altitudes in the Earth's atmosphere, and different types of clouds are associated with different atmospheric levels. For example, stratus clouds often form at lower altitudes. Cumulus clouds can form at various altitudes but are often associated with lower to middle levels. Cirrus clouds form at high altitudes. Understanding the conditions that led to the cloud formation is essential for meteorologists to predict weather patterns and understand atmospheric processes. On this table, you can see International Cloud Symbols table. But don't be scared, you don't have to know all of them. You will have to know only the most common ones. Why? Mariners need to know cloud symbols for several reasons related to navigation, weather forecasting, and safety at sea. Understanding cloud types can help sailors anticipate weather changes and make informed decisions about route planning and potential hazards. The most important cloud types for mariners are, so which one do you have to learn from this table below? Cirrus clouds. Second, cumulus clouds, stratus clouds, cumulonimbus clouds, altostratus clouds, altocumulus clouds. Understanding these cloud types helps mariners to interpret weather patterns, anticipate changes in atmospheric conditions, and plan their routes accordingly. Mariners often rely on weather charts, satellite imagery, and other forecasting tools that include cloud symbols to make informed decisions at sea. Recognizing specific cloud types allows them to gauge the likelihood of precipitation, storm activity, and other weather-related changes, contributing to safer and more efficient maritime navigation. Let's do a very small exercise. Write in the comment, what type of cloud do you see on this picture? We're gonna do a few more exercises in the next slides as well. What can you tell about this cloud type? What is the name of this impressive cloud? What type of cloud do you see on this picture? Correct, this is stratocumulus. These are low-altitude clouds that often appear as a layer of cloud cover with a somewhat uniform grayish appearance. They can cover the sky, but they are not as thick as nimbostratus clouds. And they may have breaks or patches, just like you can see them here on the picture. Stratocumulus clouds are associated with stable atmospheric conditions and might bring light precipitation or drizzle, especially if they are thickened. Oh my gosh, what is this? Correct, this is altostratus, mid-level cloud that is covering the sky and can create a hazy or milky appearance. What type of cloud is this? Oh my god, again correct! It's altocumulus, mid-level cloud that often appear as a white or gray patch, sometimes forming a layer. This is very challenging type of cloud. It's a altocumulus with turrets. You can see those turrets standing here everywhere, but don't be scared. It's not commonly used in standard cloud classification. It's just nice to know cloud. On this picture, you see cirrus with filaments. The term filaments refers to a characteristic feature of cirrus clouds. Cirrus clouds are high-altitude clouds composed of ice crystals, and they often appear wispy, feathery, or fibrous. When cirrus clouds present filament-like structures, it means that the ice crystals are arranged in elongated, thread-like patterns. Cirrus filaments are commonly associated with the upper reaches of the atmosphere, where the air is very cold, -50 degrees, and ice crystals form. These wispy strands or filaments can create intricate patterns in the sky and are often visible against a deep blue background. Cirrus clouds, including cirrus filaments, are important indicators of atmospheric conditions. They may signal changes in the weather, such as approach of a warm front or an upper-level disturbance. Despite their delicate appearance, cirrus clouds can play a role in influencing the weather patterns at the Earth's surface. And last example for this lecture, it's cirrus dance. You know that cirrus clouds are high-altitude clouds composed of ice crystals, and they often manifest as a feathery or wispy strands. When cirrus clouds become denser, it means that there is a higher concentration of ice crystals in specific region of the cloud. This densification can occur due to various atmospheric conditions, such as increased humidity or the presence of upper level disturbances. Dense cirrus clouds might partially obscure the sun or moon, creating a veil-like appearance in the sky. While cirrus clouds are generally associated with fair weather, a dense formation may be indicative of changes in the upper level atmosphere, which can influence weather patterns in the lower atmosphere. Thank you very much. See you in the next lecture. Bye.